morning. In the last class, we have started learning about many electron atoms, and we have seen that the Stern-Gerlach experiment, which proved the spin, which proved the quantum number, the existence of the spin for electrons. And today we can learn a little about the periodic table. And what is a periodic table? You have already seen in chemical chemistry and from the plus 2 classes, school classes about the periodic table. And in 1869, a Russian chemist Dmitry Mendeleev formulated the periodic law. So the modern statement of the periodic law is when the elements are listed in order of atomic number, elements with similar chemical and physical properties recur at regular intervals. So he said that, or he stated that, or he proposed that when the elements are listed in order of atomic number, we are because as the atomic number is increasing, elements with similar chemical and physical properties recur at regular intervals. So similar chemical and physical properties reoccur, that is recur at regular intervals. That is the modern statement of periodic law. So that is the periodic law. So in accordance with this periodic law, the periodic table was originated, and a periodic table is an arrangement of the elements according to atomic number in a series of rows such that elements with similar properties forms vertical columns called group, and the horizontal rows are called periods. So in accordance with this periodic law, the elements are arranged in a table that is known as a periodic table. So this is a periodic table. You can see that there are a large number of series of rows are there, and there are vertical columns. These are vertical columns as well as horizontal rows. These vertical rows are known as groups, and this is the first group, this is the second group, and this is the third group, etc. And the horizontal rows are known as periods. These are known as periods. This is one period, this is another period, etc. So there are vertical groups and periods in a periodic table. And you can see that there are these similar group, or the elements in the same group are having similar physical and chemical properties. So you can see that the first group is the hydrogen. So first group starting with the hydrogen, and the periodic table is starting with the hydrogen, and almost 118 elements are now. Earlier 105 elements were there, then 118, then there will be more than these elements because of the recurring of the properties. These scientists can be created or artificially created different elements with similar properties, and in like that and fill it in the periodic table and adding to the periodic table. So you can see that the first group is the starting with hydrogen. Then after hydrogen, these are alkali metals. These are metals plus hydrogen consist in the first group. So even though hydrogen is not a metal, all the properties, the activity, this group is highly active elements, and hydrogen is also behaving similar to this alkali metals. So this hydrogen also comes into the first group. So the different properties of the first group elements are, it consists of hydrogen plus alkali metals, which are very soft, and it is having a low melting points and very active. They are very active chemically, and you can see that lithium, sodium, potassium, etc. are comes in this group. And also you can see that the second group is starting with beryllium, magnesium, calcium, strontium, barium, rhodium, etc. These are known as alkaline earth metals, and these are all having similar properties. And the third group is starting with boron. This is the boron group, and this is the fourth group. This is the fifth, sixth group, oxygen group, and this is the seventh group. and these are known as the halogen. The highly active element is the fluorine here. These are halogens. These are highly volatile. This groups contains highly volatile non-metals and form these are diatomic molecules too, and usually in the gaseous state. So these halogens are chemically active and also oxidizing agents. Fluorine, chlorine, bromine, iodine, etc. are examples of this group, and fluorine is the highly active material here. And you can see that the group 8 elements starting from the helium, neon, argon, these are inert gases which are very inactive chemically, and there are no compounds which are connected with this inert gases because they are highly inactive in nature. So from here to here, the metallic property is decreasing and the non-metallic property is increasing. And between the group second and the group third, you can see that there are so many elements here. These elements are known as transition metals, and it is almost all the transition metals are having similar properties. And in between and from after lanthanum, this is the 57th one. After the lanthanum, this in the period 6, this is the 6th period, and there are elements which are virtually indistinguishable in their properties, and these elements after 57 to 71 is known as lanthanides. You can see that from 58 to 71, 14 elements are there. So these are known as lanthanides, and these elements are having its own properties. These are having partially filled F electrons. Here F 4F electrons. This is 4F12. This is 4F14 here. So these are the inner shell is filling. Usually the outermost shell is the empty shell, or electrons are added to the outermost shell. But here it is the inner shell. We are adding the electrons. That is partially filled 4F electrons is the peculiarity of this lanthanides. And from the 89, that is after the actinium, from 90 to 103, that is the lawrencium, we have another group, that is the partially filled 5F electrons are there. This group is known as actinide group. So these are highly radioactive element. You can see that thorium, this uranium, neptunium, plutonium, etc. are comes under this actinide series. So these are known as actinide, these are lanthanides, and these are actinides. And actinide is starting from 90 and to 103, 14 elements are there. So lanthanides and actinides. Lanthanides are also known as rare earth elements. So these are also comes under this transition elements, but a separate group, because since it is having its own different properties, some other properties are also there. So these are taken outside and named as lanthanides and actinides. So you can see that each groups, and also you can see that from, if we are going from left to right in the periodic table, the size of the atom is decreasing, and if we are going from top to bottom in a group, the size of the atom increases. That is the atomic structure and chemical behavior. There are two basic principles that determine the structure of atoms with more than one electron. That are, the system of particles is stable when the total energy is minimum. This is a natural concept. This is a default concept. Whenever the energy is minimum, the system of particles is stable. The second one is, only one electron can exist in any particular quantum state. That is the exclusion principle in a particular quantum state in an atom. So these two principles determine the structure of an atom. What is the size of the atom, what is the number of electrons in each shell, etc. will be determined by these two principles. So you can see that electrons having the same principal quantum number. We have already seen that there are four quantum numbers. One is the principal quantum number, other is the orbital quantum number, and the third one is the magnetic quantum number, and the fourth one is the spin magnetic quantum number. So the electrons are filling in principal. Electrons are having principal quantum number, and the electrons are having this orbital quantum number, magnetic quantum number, and also spin magnetic quantum number. So electrons having the same principal quantum number, that is when small n equal to 1, 2, 3, etc. When it is the small n equal to 1, then all the electrons that are accommodated in the, or the electrons occupying in the same principal quantum number, that is suppose the electrons are in the principal quantum number n equal to 1. So these electrons are occupying, we can say that these electrons are occupying the same shell. So when n equal to 1, you can see that it is known as K shell. When n equal to 2, these are known as L shell. N equal to 3, M, n equal to 4, N, etc. So if the electrons are, two electrons are having the same n equal to 1, then we can see that the electrons occupied in the K shell. When the electrons are in the having the same principal quantum number 2, then we can say that the electrons are there in the L shell, like that. And the next point is the energy of an electron in a particular shell depends on the orbital quantum number. So the energy is mainly depending on the orbital quantum number, that is L, not the principal quantum number. So the energy of electron in a particular shell depends on the orbital quantum number. Then you have already learned that for there are the orbital quantum numbers are starting from 0 to n minus 1. So if n equal to 1, the orbital quantum number will be 0. That is n minus 1, 0. Then if n equal to 2, we have 0 and 1. That is n minus 1 is 1, then 0 and 1. For n equal to 3, you will have 0, 1, 2 orbital quantum numbers will be there. So the increasing number is for L equal to 3, the electrons in L equal to 2 is having more energy than electrons in the L equal to 0 orbital state or in the orbital. So the electrons with a small l is more close to nucleus, that is it is having low energy or high binding energy. So in order to remove this uh, electron from the, since these electrons are having very less energy or it is more binded to the nucleus, we have to give more energy to take the electron outside. That is the more binding energy, so the electrons are having less energy. So in order to take the electrons outside, we have to give more energy. So electrons that share a certain value of L occupy the same subshell. So electrons sharing or electrons occupy the same principal quantum number is known as shell, and the electrons which share a certain value of L occupy the same subshell. Then if the L is same for electrons, then it is known as all the electrons are in the same subshell. So all electrons in the same subshell have almost same energy. So if there are electrons in the L equal to 0 state, then it is having almost all the electrons are in the L equal to 0 orbit is having the same energy. The occupancy or the electronic configuration for sodium, the electronic configuration or the occupancy is like this. That is 1s2, 2s2, 2p6, 3s1, etc. That is this 1s2 represents, 1s2 means the first letter or the first number represents the shell. That is, this is the first shell, that is n equal to 1 here. Then n equal to 1 means there should be L equal to 0. Only one subshell will be there, that is S. That is S means L equal to 0 is known as S subshell. L equal to 1 is known as P. L equal to 2 is known as D, etc. And two number of electrons will, this is this 2 represents the number of electrons. So for 2s2 means the principal quantum number or shell is 2, that is n equal to 2, that is the L shell. Then S means the L equal to 0 state, then number of electrons 2. Here again shell is 2, then L is equal to 1 here, that is SP. S is L equal to 0 means that is S. L equal to 1 means that is P. Then the number of electrons that can be accommodated in P is 6 here. So the representation of the configuration is like that. So the shell and subshell capacities. The exclusion principles limit the number of electrons in a subshell. For each subshell, there are 2L plus 1 different values of magnetic quantum number. So you can see that when n equal to 1, L is equal to 0, then the magnetic quantum number will be, takes the value minus L to 0 to plus L, or plus or minus L and 0 will be the magnetic quantum number value. So when L equal to 0, we have only one magnetic quantum number, that is 0. When L equal to 1, you can see that there will be minus 1. Minus 1 plus 1 is 0. Then 0 plus 1 is plus 1. So there will be minus 1, 0 and plus 1 magnetic quantum numbers will be there. So there are two possible values of spin magnetic quantum number. So for each magnetic quantum number, that is for each ml, when ml equal to minus 1, that state can accommodate 2 electrons. That is the spin magnetic quantum number. That is one electron will be in the minus 2, minus half state orientation, and the other electrons will be in the plus half orientation. So there are in each magnetic quantum number, or in each this ml state, it can accommodate 2 electrons or 2 spin. One is the up spin and one is the down spin. So if there are minus 1, 0, plus 1 state, you can see that in minus 1 state there will be 2 electrons. In the 0 state, that there will be 2 electrons. In the 1 state, there will be 2 electrons. So you can see that in a subshell, there are 2L plus 1 different values of ml. So in each ml, you can accommodate 2 electrons. So the total number of electrons will be, there will be 2L plus 1 different ml, that will be 2L plus 1 electrons will be there. In each ml, there will be 2 electrons. So the total number of electrons in each subshell can be written as 2 into 2L plus 1 electrons. So when L equal to 0, that is S state or S orbit, if the orbital quantum number is 0, that is L equal to 0, you can see that there is only 2 electrons. That you can see that in an S subshell, you can see that here only 2 electrons, here also 2 electrons. So if the orbital quantum number is P, that is L equal to 1, you can see that when L equal to 1, you can see that 2 into 1, that is 2 plus 1, 3, 3 into 2, 6. You can see that there are 6 electrons in the P subshell or P orbital. So so like that, the capacity or the occupancy of each subshell and shell can be evaluated. So the and in the next case, the maximum number of electrons that a shell can occupy can be obtained, because in each shell there are a large number of subshell. You can see that for n equal to 2 here itself, n equal to 2 means L will be 0 and 1, that is there will be an S subshell and P subshell. So there is a total of 8 electrons in the shell n equal to 2. That is 6 plus 2, n equal to 2, 2s2, 2p6 contains a total of 8 electrons. Then if n equal to 3, you can see that we will come into the example. Then you can understand it clearly. Then you can calculate the total number of electrons accommodated in a shell. That you can see there is an equation for that. That is, the maximum number of electrons that a shell can occupy is n max is equal to, because you can see that each subshell is containing this much number of electrons. 2 into 2l plus 1 number of electrons. Then there are a large number of subshell will be there in a shell. That is, the subshell can be ranged from L equal to 0 to L equal to n minus 1. So you have to calculate the total number of electrons in a shell using the equation summation L equal to 0 to L equal to n minus 1. That means if n equal to 3, there we have to sum from L equal to 0 to L equal to 2. Summation 2 into 2l plus 1. That is, you can say this is equal to, then when L equal to 0 means L equal to 0 means this is 1, L equal to 2, 1 means this is 3, etc. So 2 into 1 plus 3 plus 5 plus etc. 2 into up to n minus 1 plus 1. So 2l plus 1 means 2 into n minus 1 plus 1, which is equal to 1 plus 3 plus etc. This bracket you can remove, 2n minus 2 plus 1, that is minus 1 here. So this is the equation here, and the average value of this term in the bracket can be obtained. This is the average value. That means you can calculate if there are this is the average value of quantity in the bracket can be written as half into 1 plus 2n minus 1. You can give as an example, if n equal to some 2, n equal to 2 means there will be 2n minus 1 means you can calculate 2n minus 1 means n equal to 2 means 2 into 2 minus 1, that is 4 minus 1, that is 3. So you have 2 into 1 plus 3, that is 3 plus 1 is 4, 4 into 2 4. Then the average value is you have to divide by n. What is n here? N is, we have taken n is equal to 2 here. So 4 by 2 means 2. So the bracketed term contains, the value of the bracket will be 2. If we can just check using this equation, when n equal to 2, here you will get 2 into 2, that is 4 minus 1 3, then 3 plus 1 is 4, again it is 2. So the quantity in the bracket, the average value in the quantity, the bracket can be written as half into 1 plus 2n minus 1. So the first term plus last term divided by 2. So n max can be written as, so this is the average value here. This is the average value. This term is the average value. Plus 2 here. 2 is there always. 2 into. Then this is the average value. So we are dividing this term by n to obtain the average value. So in order to get the total number, we have to multiply this term used by n. So you will have 2 into n into this quantity is the total number. This is not the average value, the total value. So 2 into n into this average value gives. Then you can remove, this will get cancelled. Then this 1 and minus 1 will get cancelled. So 2n square values will be there. So for K shell, you can see that for K shell n equal to 1. So the maximum elements or electrons in the K shell is 2 electrons. That is 2 into 1 square. That is 2 electrons. That you can see here. That is, this is for n equal to 1 is a K shell. N equal to 1 means L equal to 0. L equal to only one subshell will be there. That is L equal to 0. Then L equal to 0 can accommodate 2 into 2l plus 1 number of electrons. That is 2 into 2l plus 1 means 2 into 2l means 0, that is 2 electrons. So the first K shell can be accommodate only 2 electrons, that is 1s2 will be there for the K shell. So we can take another example. As an example, n equal to 3. This is M shell, KLM shell. So the values for L, n equal to 3 means the values will be 0, 1 and n minus 1, up to n minus 1, that is 0, 1 and 2. So there are the ml values, usually the ml values is minus L, 0 to plus L. So for L equal to 0, that is the S subshell, there will be 12 plus 1 ml values, that is 2 into 0 plus 1 ml values, that is only 1 ml values will be there. So for ml equal to 0, there will be two orientations, that is ms equal to minus half and ms equal to plus half. That means there are two electrons in an s subshell. So in an s subshell, that is when L equal to 0, there are two electrons. The next one is the 1, the subshell number, that is 1. For L equal to 1, that is the P subshell. You can see that ML will take 2L plus 1 values, that is from minus L to plus L, or plus or minus L and 0, that is plus or minus L and 0, that is minus 1, 0 and plus 1. So we can take each one by one. So when ml equal to minus 1, ms will be minus half and plus half. Again ml equal to 0, ms will be minus half and plus half. Then ml equal to plus 1, ms will be equal to minus half and plus half. So you can see that when L equal to 1, that is P subshell, there are 2 plus 2 plus 2, there are 6 electrons that can be accommodated in a P subshell. That is, you can see that here for P, there are 6 electrons that is accommodated in the P subshell. So this is the P subshell. The next is L equal to 2, that is SPD subshell. When L equal to 2, that is the D subshell, then you can see that the number of electrons. So when L equal to 2, that is the D subshell. So this ML will take 2L plus 1 values, that is ML have 2, L is equal to 2, there will be 5 values for ML, that is minus L2 plus L through 0, that is minus 2, minus 1, 0, plus 1 and plus 2. So for ml equal to minus 2, ms will take these values. ml equal to minus 1, again 2 electrons. Like that, ml equal to plus 2, again ms equal to minus half and plus half. So here 2 plus 2 plus 2 plus 2 plus 2, there are 10 electrons that can be accommodated in a D subshell. That is, usually you can see that 3D10 like that. That is, when L equal to 2, you can that is the D subshell, and a D subshell can accommodate how many number of electrons? 10 electrons can be accommodated in a D subshell. So there are 10 electrons in a D subshell. So a total of, so we started with the n equal to 3. So you can see that for n equal to 3, there are different L values. So for each L values, the first L value is 0. First L value is 0. So there are 2 electrons that can be accommodated in the L equal to 0 state. For L equal to 1 state, there are 6 electrons. For L equal to 2 state or L equal to 2 subshell, there are 10 electrons. So when N equal to 3, you can accommodate this 2 plus 6 plus then 10. So 2 plus 6 plus 10, that is equal to 80. That you can see that the total number of electrons that can be accommodated in a shell is 2n square. So when n equal to 3, 3 into 3, that is 9 into 2, 18 electrons. That the same number you can obtain using the when we are splitting all the or when we are calculating, when we are counting the electrons in each subshell, you will obtain the same 18, that is 2 into n square values, 2 into 3 square values, that is 80. So there are 18 number of electrons that can be accommodated in the M shell. Then for L shell, that is 2 into 2 into 2, that is 8 electrons that can be accommodated in a n equal to 2 state. That is, here you can see that when n equal to 2, n equal to 2, this is n equal to 2, this is the shell, and that is total of 8 electrons will be there in the n equal to 2 shell or L shell. So these are the calculation, or these are the capacity of the shells and subshells in an atom. In a similar way, you can calculate if n equal to 4, n equal to 5, etc. You can obtain the total number of electrons that can be, how the electrons are distributed in different subshell of a shell, and as well as the total number of electrons in a shell. So next I will give you some work. This work you have to do, that is how the chemical behavior like binding energy, ionization energies are changing in accordance with the atomic number, or in a group, or in a period, how these energies are changing in each element across a period. And also you have to learn the Hund's rule. What is a Hund's rule? So next we can take the different coupling schemes. That is how the total angular momentum is can be calculated using the or the magnetic quantum number, as well as the spin magnetic quantum number. How we can calculate the total angular momentum J using the L and S values. That we can take in the next class. Now we can stop. Thank you.